Hello, you're watching the demonstration video for the Parr 6725 Semimicro Calorimeter with the 6772 thermometer and the 1109A Semimicro oxygen bomb. Okay, so to get started, you're going to want to moisten the bomb parts, including the O-ring, which is important because you want to make sure that the experimental conditions for your sample are the same as, say, you were running a number of samples, which you will probably be doing one right after the other. You're going to have some residual water in the bomb itself, and so you want to make sure that the experimental conditions are the same for your sample each time. So I have the bomb head placed in the service stand here that's provided. You can buy it from the company, and this is the setup used to tie the fuse to the bomb head. So you're going to cut off 10 centimeters of fuse and tie it according to the instructions provided in the manual for the bomb. So I've tied the fuse inside the bomb head, and mine never really does, I don't think, come out the same way as the manual has it, but it's nice and sturdy. To make these coils, they suggest using an Allen wrench, but I just use the pin wrench that came with the bomb. And you might notice that the hanger for the fuel capsule might get in the way. So what I just do is just take that and swivel it off to the side to make room for preparing the fuse. Alright, so next you're going to take your fuel capsule and put it on the weigh scale and tare it. And I have some tissue sample here that's been drying in an oven 24 hours at 60 degrees. So that's the stuff that I'm going to be testing today. So once you have that tared, you're going to fill that fuel capsule up with your sample. Okay, so I've turned the bomb head over in the service fixture and weighed out 0.11 grams of our sample. And I've carefully placed the fuel capsule in the fuel capsule hanger here and swiveled it back underneath the fuse. And if you find that the fuse is in the way of the sample, you can just pull up on the sides a little bit to raise the coils above the sample so it doesn't knock it over. And so the bomb parts should already be nice and moistened. If there's any really large droplets of water in there, you can just blot them up. So we're going to carefully take the bomb head and place it into the cup. And then thread this over the bomb. So once your bomb is assembled, you're going to take it over to your oxygen tank with your pin wrench. And there's 4 valves that you need to be familiar with here. On the regulator in the tank, you have the tank's valve, the regulator valve, and the relief valve. And then there's also a valve on the oxygen bomb. The valve cap, it's the highest point here on the bomb. So to begin filling the oxygen bomb with oxygen, you're going to take your coupling, which is attached to the regulator, and place it over the valve cap and press it down gently until you hear it or feel it click rather, and then you know that it's in place. Then you're going to take your pin wrench, put it in the hole on top of the valve cap here, and just open it 1/2 turn. So now the valve cap is open. Now on the tank, you're going to open up the tank valve about 1/4 turn. And you see I have some pressure built up in the regulator. So then you're going to turn the regulator valve very slowly until you get about 30 atmospheres of pressure built up in your oxygen bomb. So you don't want to exceed 35. So 30 should about do it. Then you're going to close your valve cap by turning your pin wrench all the way back. Then you're going to open up the relief valve and release the pressure so that you don't get a blast of air when you take off the valve, the coupling from the valve cap. And then you pull out your pin wrench and just carefully pull up on the coupling to remove it from the valve cap. Okay, so the bomb is now ready to go. What you need to do next is fill this dewar with 450 milliliters of room temperature distilled water. And place that back in the Semimicro Calorimeter. Okay, so what you're going to do next is take your bomb and put it in the bomb hanger. And then you're going to take the bomb with the hanger and place it in the dewar flask. So here's the bomb inside the dewar flask filled with water. And 450 milliliters of water should be enough to allow the water to come up above the gas inlet hole on the valve cap. So once it's in the bucket hanging on the side, just check to make sure that there's no air bubbles leaking from the bomb. If that's the case, don't run the test because the bomb will need to be serviced. So once it's in the dewar flask, I hang it over to the right hand side because once the cover is on, the stirrer is actually going to hang on the left hand side. So you can go ahead and connect the leads. One in the bomb hanger and one in the terminal end of the bomb head. And you can place the cover on. And just make sure that the stirrer is not hitting the bomb or anything inside of the calorimeter. And once that's okay, you can go ahead and attach the belt. So the belt is attached, and there's a little groove underneath the calorimeter's cover for the lead wires to fit into. So make sure that's in there so that the cover is lying nice and smoothly on top of the calorimeter. Now, if this is your first time running a series of samples through, then you'll first need to standardize the calorimeter with these benzoic acid pellets here. And the procedure is pretty much the same. You'll just need to change the settings in calorimeter operation from determination to standardization, and it's just a toggle switch, so you just hit that once and it'll change it. So this one's already been standardized with benzoic acid pellets, so we're going to go ahead and run the test. So everything is pretty much already set up and automated, so you just go ahead and you select start, and that's going to run the stirrer, so it's stirring there now. So it's going to ask you for sample ID, which it's going to select for you. For us it's number 57 here, so we'll hit yes. It's going to ask us for the bomb ID, and then for this lab we just have the one bomb, so it's just going to be number 1, so we hit enter. Next it's going to ask you for your sample weight, so we're just going to put in 0.11 grams and enter. And so on this menu here, it's actually giving you a progress bar, so you can keep track of the progress of the combustion. And if you want to keep track of the temperature, you're going to hit temperature graph. And so it gives you two lines here. It gives you a black line and a red line. The black line is the jacket temperature. The red one is the bucket temperature in the dewar flask. And so for a period before the combustion actually starts, it's going to make sure that the temperature for both of those thermometers is stable. And once it's convinced that both temperatures are stable, it's going to initiate combustion. So once the calorimeter is convinced that the temperature in both thermometers is stable, it's going to initiate the ignition, and it's you'll hear 4 or 5 beeps when this happens. And on the graph you'll see a rise in the temperature in the bucket. So what's happening is when the sample undergoes combustion, it's driving the temperature up in the water in the bucket, and that's what you're seeing here. So it's going to continue to read this for probably between 5 to 10 minutes until it's convinced that the temperature in the bucket is no longer increasing. So when the test is finished running, the belt is going to stop and there's going to be a short safety delay. But when the progress bar says idle, you can go ahead and take the bomb out of the bucket. So once you've removed the bomb from the Dewar flask, you'll need to check inside of it to make sure that there's no unburned pieces of sample left in there or a lot of ash. If that's the case, then you'll need to disregard that reading because it won't be accurate. So to open up the bomb, you're going to need to insert the pin into the valve cap and open it up slightly to relieve the pressure that's inside. If you forget this step, you'll know because you won't actually be able to unscrew the cap from the bomb. There's too much pressure built up inside. So, using your pin wrench, just going to slowly let that out. And if you're doing any titrations, you'll need to do this process over the course of about a minute or so. So I guess so you don't lose any of the material that you're looking for, but we're not doing any titrations here, so I'm just going to go ahead and let that all out. So you look inside the cup and we don't have any large pieces of ash or unburned sample. There might be some spots on the bottom from pieces of fuse that fall down and sort of burn down on the bottom of the bomb. So on the bomb head here you see these little unburned pieces of fuse. What you'll need to do is remove those pieces of fuse, straighten them out, and get the total length for all the pieces. Now to see the results of your sample, you're going to select Report on the right hand side of your screen and select from List. So your test is going to be the most recent one at the top of the list here, so make sure that it's highlighted and you can select Display. So it's going to ask you for the fuse calories. 2.3 calories per centimeter is given off when the fuse is burning, and more often than not the value is 15 calories, which is what the calorimeter assumes. If you calculate it yourself, when you measure the unburned fuse, like I did, I had 4 centimeters of unburned fuse, so I had 6 centimeters of fuse that did burn, and that contributed 13.8 calories to my sample, so that needs to be corrected from the actual value. So we can leave it at 15, or we can enter in our calculated value, which was 13.8, and enter. It's going to ask you for the final sulfur as well, which we don't know in this case, but we're dealing with a tissue sample here, so it's nothing that we have to worry about. So the calorimeter does the calculation for you, and on this screen it gives you a summary of the values used to calculate that final value. And the final value was found down here on the bottom right hand corner of the screen. So in our sample we had 4,651 calories per gram. And that is how you operate a Parr 6725 Semimicro Calorimeter. Thanks for watching.